Ladies and gentlemen, welcome to another video on my channel. Are you ready to bring your Python skills to the next level? Following this video, you definitely will. So let's take a look what we will cover in this video. We will take a look at Jupyter Notebook, typecasting, the input function, list indexing and slicing, conditionals, both loops in Python, and in the end, I'm giving you some tasks to consolidate your knowledge. Really annoying for you, really important for me. Before we start, if my videos are helpful, please consider supporting this channel by liking, subscribing and commenting. I thank you very much in advance and I thank everyone supporting this channel from the bottom of my heart. Let's get into action now. Before we start, from this tutorial on, we will switch from IDLE to Jupyter Notebook, which is another environment to code in Python. So let me quickly show you how to install Jupyter Notebook on your PC. Open up your browser and type in anaconda.com. On this side, click Get Started and install Anaconda Individual Edition. Scroll all the way down, and here you are picking the graphical installer. Of course, if you're using Windows, then click this one here. Once you've done that, Anaconda is being downloaded. Once the download is completed, click on the installation file and go through these instructions here. Of course, I've read them all beforehand. So I'm just clicking continue, continue, continue here, agreeing to everything, and picking install for me only. Then continue and install. After some minutes you will get this screen here, and this is telling you that the installation was successful. Okay, now we want to start Jupyter Notebook, and this is done by opening up our terminal. And here we are noticing this base in front of our name. If you're interested in the details behind that, please click my video on the Anaconda environment. Nevertheless, here, just type in Jupyter Notebook and you will notice an opening window in your browser. Here, you are seeing your user folder, so this may look different for you. To actually get started, click on New and then Python. And here is your environment. Let's understand what's going on here. This is a cell, and inside the cell, you can write Python code. So let's take an example here. Let's define x as 5. How can I execute this? By clicking this Run button here. If we are doing that, we are noticing that a new cell has been created and that this cell has been executed. So let's call x by just typing down x here and run this cell. And as you see, we are getting the 5. So everything went better than expected. We can also get back to already executed cells and do amendments. So let's take an example for that. Let's get back to the very first cell and assign a new value to x, for example 10, and execute the cell again. Now, if we are executing this cell again, which is now 5 because we didn't execute it newly, and run this again, we are getting 10 for x now. So you can do amendments for already executed cells. I mean, how awesome is that? Not only single lines of codes are possible inside a cell. Let's take an example. Let's define y as 4 here. And now just press enter and you are getting to the next line. And you could define a new variable here. For example, z as, let's say 6 here. Now we could also execute this, let's call it script, by just clicking run again. And now this has been executed. So if I want to get access to these variables again, I could type in y here and run this cell and I'm getting the 4. And also I could call z and getting the 6 here. An alternative solution to get those variables would be to print them out. So let's do that by using the print statement, and then we are printing out y, getting to the next line and printing out our z variable here. So let's execute that again by clicking run. And now we're getting both variables. What's important to understand now is you could also use those print statements right inside this code here. So we could use print y and print z inside this code here. And if we're running this, we would get the output of 4 and 6 here. Let's take a look at some more useful features before we're moving on. First, how can I get rid of cells? By just clicking this scissor symbol here. So now the cell has been deleted. To insert additional cells, click on Insert, and then dependent on where you want to have this new cell, click on Above and Below. So above would be above our selected cell, which was this one here. What I'm using pretty often to keep a better overview of my notebooks are markdowns. How do that work? Let's just insert a new cell here, and I could call this Python Introduction, and I'm just picking Markdown here instead of code. Okay, and now if I'm executing this cell, I'm getting a heading of this notebook. So you will find that pretty often in my notebook, so just that you are not confused. Okay, now we are ready to move on, but let's create a new notebook for that. So click File, New Notebook, and then Python 3. Let's get started. Let's start with typecasting in Python. As you remember from the last video, we have 4 data types in Python. I already assigned all of those data types into different variables here. So for example, W is an integer, which was a whole number, X is a float value, which was a decimal number, Y is a string value, which was just plain text, and Z is a Boolean value, which can be true or false. Now, how do I typecast in Python? Let's execute that and start with integer typecasting. So let's actually name that integer typecasting. So we want to perform a typecast of a certain data type to an integer. So let's execute that and actually make that a bit more beautiful here. So we are starting with integer typecasting, okay? So we have 3 options here, right? So this is an integer, so we don't have to do a typecast here. This is a float. So let's start with typecasting a float value. How do we do that? By just typing an int for integer, and then we are providing x as the argument for the typecast. And as an output, we get the integer version of x, which is a float value right now. So let's do that. And we are getting a 3. So if we are performing a typecast or an integer typecast of a float value, we end up with the decimal number, but without the decimal. Okay, so this is just being cut off here. So we are not getting a rounded value, which you could expect, but we are just getting a cut off value of the first digit here. Okay, so this is important. Next one would be an integer typecast of the string value y here. So let's provide y as an argument here. And here we are getting an error message. So this is not possible in Python. You can't perform a typecast to an integer from a string on. Next one, z, which is a Boolean value. Let's see what's happening here. Now we are getting a 1, and this makes somehow sense, right? Because we learned in the last video that the Boolean of true is corresponding to 1, while the Boolean of false is corresponding to 0. Let's move on to the next typecast, and that is a float typecast. So let's type that down, float typecasting, and let's make that beautiful again. And now let's start. So we are using float now, same logic as above here. So we are starting with an integer here, so w, which is 5 in the moment. So let's see what is happening. We are getting a 5.0. So this is again somehow logic, right? We have a plain 5 here, and if we are transforming that to a decimal, we would get 5.0 here. If we are typecasting a string value here into a float value, we are again getting an error message. So this is not possible in Python. And last one would be the Boolean value. And this would give us 1.0, which again makes totally sense, right? Because we know z is corresponding, or true is corresponding to 1. And this is why this is 1.0 here. Next one, string typecasting. And let's just change that here so that we don't have to necessarily scroll around here. So this is string typecasting, and we're using str here. And we're starting with an integer typecast into a string. So we are using w here and execute that. And we are actually getting the integer value as a string value here. So this is possible in Python, and you will use that a lot of times, I promise you. The next one is a float, and this is the same logic. We are just getting the float value as a string. So this is perfectly possible, right? The next one is a Boolean typecast, so Boolean to string, and this is just giving you the string of true. So this is not, as you might have expected, a 1 or something like that. This is just the text true if you are typecasting a Boolean to a string value. Next is the Boolean typecasting. So let's just change that here to Bool typecasting or Boolean typecasting. And now we are starting again at our W here, which is an integer, and we are getting a true value. Because, and that is pretty important to understand, every value different from 0 is giving us a true value when we are doing a Boolean typecasting. Even if we're doing, and let's do that, a Boolean typecasting of a negative value, so let's take -1 here and execute that, we are getting a true value, okay? But if we are taking a 0 here as the argument, we're getting a false value. Or even if we are taking a 0.0, we are also getting a false value. But if we are taking a 0.01 here, we are getting a true value, okay? So again, every value different from 0 is giving us a true value when we're doing a Boolean typecasting. Next typecast, float to Boolean here. So let's do that. And this is the same logic now, right? So if we are performing that, we're getting a true value as well. And that is because this float value is different from 0 again. So let's move on to the next one, which is a string value. And that's actually pretty interesting. So if we are performing that, we are also getting a true value. And that is because every letter in this string is assigned to a numerical value. You might have heard of ASCII values. If you're interested in details on that, check the video description or click the video in the right corner. Now let's take a look at the input function. We are typing down input here and we're just using parentheses afterwards without anything inside them. So let's execute that. And now we are asked for an input here, and you could type in anything you want here. I'm typing in hello here without quotation marks. If I'm pressing enter now, I'm getting an output of hello as a string. This is really important. So let's take another example. Let's execute that again. And now we are providing a numerical value such as 5. And if we're executing that by pressing enter, we are getting a string of 5. Okay, this is really important. So we are always getting a string value out of our input, no matter what we are providing, okay? We can make this function more meaningful by providing a text inside those parentheses here. So we are asking the user which value so that he knows what he has to provide here. So if we're executing that, we're actually being asked for something to provide, okay? So this is more meaningful, right? So let's take 5 again here. And now the output is the same. Nothing has changed here, right? So we could actually add a space here to make this even more beautiful. So we are doing that again, and we are getting a 5 as a string again, okay? You can use this input function now to do flexible variable assignments. Let's take an example for that. So I could type in x equals 2 and then input, and then let's just ask which value for x. And for executing that, we could provide, for example, 10 here. And if we are printing out x here, we are getting a 10 for x. And as you see, even though I've provided 10 as a numerical value, I'm getting the 10 as a string here. So we can actually check that by using the type function. And as you see, we're getting string here, right? So how can I avoid that? Well, we've already learned about that. You can use typecasting for that. So let's amend this input here by just using an integer transformation of this input here. So we are just typing an int here, use parentheses and close this parentheses, and we are executing this again. And now we are providing again a 10 and printing out x again. And now you see we are getting 10 as an integer. And if we are using type function again, you see that we successfully stored an integer of x. Let's do a final example. Let's get rid of all those cells here. Let's program a very simple calculator. We are defining x as, and now we are using the float typecaster. And now we are using again the input function and ask which value for x. And in the next line, we are defining y, again with the float typecaster and which value for y. And now we are just adding up those provided values. So let's execute that and see what is happening. Now let's take 10 for x and 5 for y. And now we are getting 15 as an output. We could also provide float values here, and this is why I'm using the float typecaster. So we are taking, for example, let's take 3.5 and 2.5 here, and then we're getting 6. So pretty cool, right? Next important concept, list indexing or indexing in general in Python. Therefore, let's define a list, and we're just naming it list1 here. Let's just use some numbers here, so for example 2, 4, 6 and 8, and let's execute that. And now, how does indexing work? Indexing starts counting at 0, meaning the 2 here is the very first element of this list, and this element is stored at the index 0. The second element is stored at the index 1, and the third element is stored at the index 2, and so on, okay? So how to get access? We are defining the list name now, opening up squared brackets, and inside those squared brackets, we are defining the index. So if I'm defining 0 here, so index 0, and I know that counting starts at 0, we are getting the very first element, which is 2 here. So as said, we are getting 2 here. So as another example, if I'm taking the 1 here, we are getting the 4, and so on, okay? So again, if we're taking the 2, we're getting the third element here, and so on and so forth. So I also can start counting from the end of the list by just defining negative numbers here. So if I'm taking -1 here, I'm getting the 8. If I'm taking -2 here, I'm getting the 6, so the second last element from this list. And for now, that's already it for indexing. If you got the concept of list indexing, you can move on to list slicing. List slicing is used to get a share of a certain list. For example, only the first 2 elements here. And let's actually do that. We are accessing the list by calling the name of the list, and then we are opening up squared brackets. First, we have to define the start value, and as we are interested in the first 2 elements, we are starting at index 0 to get the 2 here, right? So we are starting at the 2. So 0 is our start value, and this value is included. Now we have to use a colon, as shown here in the syntax. And now we have to define a stop value, and this is somehow different to defining a start value, because the stop value is excluded. So this is in mathematical terms n-1. So if I want to get the first 2 elements here, which are at index 0 and index 1, right? I have to get the stop value of the third element here. So this is at index 2. Again, 0, 1, 2. So I have to include the 6 because the 6 is being excluded when slicing this list. Kind of confusing, right? But you have to practice it sometimes, and after a while it does make sense. So let's execute this and see what is happening. And yes, we're getting the first 2 elements. Let's take one more example here, and let's just stop at 1 here. So at this index here, at the 4, and see what is happening. Now we are only getting the 2 because the 1 is being excluded, and we are only getting index 0 here, okay? Without the intention to confuse you even more, I want to cover list slicing with negative values. So let's do that. Let's access list 1. We're defining the start value as -4, and the end value, let's take -2 here. And we're executing that, and we are getting 2 and 4. Why? We are starting to count from the right side. So we are taking -1, -2, -3, and -4. So this is our starting value. So this starts at 2, right? And for the stop value, the same. We are starting to count from the right. So -1, -2. So the 6 is our stop value. And the 6 again is excluded because it's our stop value. So we end up in 2 and 4 because we are starting at -4 and we get to -2, and the -2 is excluded. Okay? Now I'm reading this question pretty often. When we are changing the stop value to, for example, 0 here, we are getting an empty list. Why? Because the logic is the same as before. We are starting to count at -4. That is -1, -2, -3, -4. But our stop value is at 0, which is in the same place here. So to break this down, you have to make sure that there are values to the right of your starting value. Next important concept, conditional statements. They are used to perform certain actions when a condition is fulfilled. Let's take an example here. So let's define x as 10, And we want to check if x is larger than 5, which is actually true, right? But just as an example, we have to type in if x and then using the larger than operator, 5, use colon now, and notice what is happening when I press enter now. We are landing here. And this is called an indentation in Python. And that is basically just telling us that we should define an action if this if statement is fulfilled. So we could just print out stuff here. So we could print out yes, for example, here. So if we are executing that, we are getting the yes because this condition is fulfilled. Now let's take the example of this condition not fulfilled, and that is done by just amending this to 11 because x is not larger than 11, right? And if we're executing that, we're getting no output as we've only defined to print out yes if x is larger than 11, which is not the case here. But I actually want a feedback here, so how can I achieve that? We need to define an else statement here. And this else statement has to be defined outside this indentation here. So we have to go back to the very left here again. So we are defining else here using colon and then press enter. And now we are back in the indentation of this else statement here. So we have to define the action if this condition is not fulfilled. And that is what the else function is for. So we are just printing out no here. Okay? So if we're executing that, we're getting no because x is not larger than 11. So this is working like this. This condition is checking if x is larger than 11. This is not triggered. So this is being triggered and no is being printed out. For understanding the Elif statement, let's take a new example. So let's get rid of all those cells here and let's set up the variables we need for this example. So we are working with x, which is an integer typecast of the input. And then we're using what value for x. And the y is also an integer input of what value for y here. So this is what we have just covered, right? This is nothing new here. Now let's firstly perform a simple if statement here. So let's check if x is larger than y. We want to print out x is larger than y. Okay? So also we want to print out y is larger than x if this condition is not fulfilled. Okay? So let's execute this script and let's provide a 10 for x and a 15 for y. And we are getting the output y is larger than x. And that is because this statement is not being triggered as x is 10 and y is 15, and the else statement is being triggered. And now let's execute this again. And I'm providing the exact same values for x and y. And I'm still getting y is larger than x, which is wrong. This is happening because this condition is not being fulfilled, right? So 10 is not larger than 10, resulting in the else statement being executed, which is giving us y is larger than x. So we have to provide an additional condition here, and that is done by using the elif statement. So let's actually insert that here. So we have to define the elif statement such as the if statement. We have to provide the condition here. So we are using x, and now very important, double equals two signs, y, and now we have to define the action again in the indented area. So we are using print x equals to y here, okay? And that's actually it. So let's execute this whole script again and see what's happening. We are providing the same values for x and y, and now we are getting x equals to y, okay? Let's actually check for the other cases. So we are providing a larger value for x as y, 15 and 10 here, and we are getting x is larger than y, and finally 10 for x and 15 for y, and we are getting y is larger than x. So works perfectly, right? And that's it, what you need to know for if statements. Next important concept, loops in Python, and we are starting with the for loop. The for loop is just iterating over an iterable object. An iterable object could be, for example, a list. So let's create a list first. And let's just take 2, 4, 6, and 8 as the elements. Now I want to print out every element inside this list, and that can be done by using a for loop. So the syntax of a for loop is for I in list 1, and then we have to define a certain action. So we are just printing out I here. So what is I? I is the certain element inside this iterable object. So the iterable object we have defined here is list 1. And every element in list 1 is 2, 4, 6, and 8. So if we are running this, we would get every element inside this list 1. So that is basically how a for loop is running, right? So you need an iterator or an element and the actual iterable object here, right? So let's take another example for a for loop, and that would be for I in range. So you can actually perform for loops in a certain range. Let's just define 0 to 5 here, okay? And now, same syntax as above, we just want to print out every element inside this range. And if we're executing that, we are getting 0 to 4. Again, the stop value, it's the same thing as when slicing lists. The stop value is excluded, and that is why this loop ends at 4 here. And also, the start value, which is 0, is included here, as you see. So these are two possible applications of the for loop. Let's get back to the first example. I want to show you one more thing here. You could actually do some calculations with those elements here, right? So we could add a 1 up to each element by just typing in I plus 1 here and perform the loop, and now we are getting every element plus 1 here, right? Or for example, you can also use times 2 here, and now you're getting 4, 8, 12, and 16, and every other calculation which you can imagine. Finally, let's go back to our second example and add an if statement inside the for loop. So we want to print out only those elements which are larger than 2. Okay, so we are defining if I is larger than 2 here, and we have to care about the indentation now. Because this is referring to both the for loop and the if statement, it has to be indented 2 times, right? So we have to click the tab here and care about that this print statement is indented in the second area here, right? So if we're printing this out, we are getting 3 and 4. So everything went better than expected. If statements inside for loops, also pretty important to understand. Last but not least, while loops. So what is the difference between a for loop and a while loop? The for loop is working in a certain range, and this range could be from an object, for example a list, or from the individual defined range with the range function, as we saw. Contrary to that, while loops are looping until a certain condition is fulfilled. Let's take an example for that. I want to count until 10 here, okay? So you could actually code that with a for loop, with the previous knowledge you got. But I want to code that with a while loop. So what do I have to do? Well, I have to define my starting point, and that is I equals to 0 here, okay? And now I'm defining the while loop. So what is the syntax behind a while loop? You're typing down while, and now you have to define the condition until the while loop is running. So that would be, in our case, I is smaller than 10, because we want to count until 10 here, right? And inside this loop, we want to add a 1 to this I with every iteration here, okay? So this is basically just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And of course, we want to print out every step of this iteration here, right? So if we're executing that, we are getting what we wanted to get. So that is 1, 2, 3, 4, and so on and so forth, okay? By the way, with the for loop, it would be very easy. So we are just defining for I in range and then 1 until 11 here, and we could actually just print out I here, and then we got the same result here. Just to do a comparison here. Let's take an additional example here. So let's define points as 0 here. Now my goal is to be asked to provide my points until I have reached at least 10 points. So let's code that with a while loop. So we have to define while, and then points are less than 10. And now I want to be asked again. So that is points equal to, and now we have to get an integer typecast of the input. So that we have already learned. That is int of input, please provide your points. And if I'm executing that, and I'm just typing in 5, 4, and so on, as long as I'm not providing a value which is at least 10, I'm being asked to provide a value. So let's continue this game with 3 more steps here, 2, 8, and now let's finally take 10. And as you see, I'm not being asked for any more input here as the while loop condition is fulfilled and the iteration stops. Last example, we can also perform infinite while loops, and that is done with the following syntax. We are typing down while true and then what should be done. So we are typing in infinity here because this is running until the end of time, okay? So as you see, we are getting an endless output here. And we actually have to manually stop the script. And now I'm showing you a different thing here. If I'm amending that to false and executing that, this loop is not being executed, okay? If I'm amending that to 1 here, this loop is being executed, okay? So as long as you have a Boolean value here, which is equally to the Boolean true, and that is every other value than 0, this loop is running until infinity. Now it's your turn, time to practice. And my recommendation is to solve these tasks with pen and paper. First one, what is the output of the following code? A Boolean of 5 and why? Second, write a program multiplying two numbers which are provided by the user. Third one, you have a certain list, ABC. You should give me the output of the list with this slicing and tell me why this output is happening. And you should provide a solution to this problem. So I don't want to get what I'm getting here, okay? The next task, define a loop printing out every value from 1 to 10, and you should skip the 5. The next task, and this is a pretty tough one, so try to solve this, but don't be demotivated if you can't solve that. Your mom is asking you to program a shopping list with individual input. Her shopping bag is capable of 5 items. And I have some hints here. Hint 1. Length of a list can be used by the function lang and then the list name. Hint 2. You can append items to list by using the append function. 3. An empty list is created by list name and then using squared brackets. The next hint, you can solve this either using a for loop or a while loop. That's it. Thank you very much for watching. If this was helpful, please support this channel by liking, subscribing and commenting. I'm seeing you in the upcoming videos. I'm looking forward to it. Thank you very much again. Bye bye.